Obtain Taylor series expansion of log 1 plus x divided by 1 minus x. We know from Taylor series expansion that a function fx is equal to fa plus x minus a divided by factorial 1. The first derivative of the function at x equal to a, then x minus a whole square divided by factorial 2. The second derivative of the function at x equal to a, and we will take up to the nth derivative, and here we will take the function at a equal to 0 or at x equal to 0, and the Taylor series here is called Maclaurin series, and the given function is fx is equal to log 1 plus x divided by 1 minus x, can be written as log 1 plus x minus log 1 minus x. It can be, you can use the formula log m by n, that is log m minus log n. So using the formula log m divided by n, that is equal to log m minus log n. So the function is log 1 plus x minus log 1 minus x, and first term is to find out the function at x equal to 0 or f0. So if you put x equal to 0, then this will be equal to log 1, and this will be also log 1. Log 1 will be is equal to 0. So f0 is equal to 0. Then we will calculate the first derivative of the function, that is f dash x, that is equal to, if you take the derivative of this function, that means derivative of log 1 plus x is equal to 1 divided by 1 plus x, and derivative of 1 plus x is equal to 1, and derivative of log 1 minus x is 1 divided by 1 minus x, because derivative of log x is equal to 1 by x. So derivative of 1 minus x is equal to minus 1. And so if you simplify it, 1 divided by 1 plus x minus, again minus, it is plus, so 1 divided by 1 minus x. So if you add those two terms in the denominator, you have 1 minus x square, and the numerator you have 1 minus x plus 1 plus x, so it is equal to 2. And if you find out the derivative of this function at x equal to 0, at x equal to 0, this term will be equal to 0. So the derivative at x equal to 0 will be equal to 2 divided by 1 is equal to 2. So f dash 0, or the first derivative of the function at x equal to 0, is equal to 2. Now we will find out the second derivative of the function. If you differentiate 2 divided by 1 minus x square, differentiate with respect to x, then what will be the derivative? 1 divided by 1 minus x square, that is equal to minus 1 divided by 1 minus x square whole square, and derivative of minus 2x minus x square is equal to minus 2x. So if you simplify it, minus, again minus, it is equal to plus, so 2 into 2x, that is equal to 4x. In the denominator you have 1 minus x square whole square. So what will be the second derivative of the function at x equal to 0? At x equal to 0, and this term is equal to 0, so in the denominator you have 1, and in the numerator you have 0. So second derivative of the function at x equal to 0 is equal to 0. Now let us find out the third derivative. For third derivative, this is in the form of division function u by v. So the derivative of this function will be equal to the third derivative, and that is equal to the v, that is in the denominator 1 minus x square whole square, and derivative of u in the numerator, that is equal to 4 minus 4x into derivative of 1 minus x square whole square, that is equal to 2 into 1 minus x square into minus 2x divided by 1 minus x square whole square, square, the square of this quantity, this function, that is equal to 1 minus x square to the power 4. So if you simplify it, the first term will be equal to 1 minus x square whole square. Here you have to the power 4. So in the denominator you have 1 minus x square whole square, and in the numerator you have 4. Then the second term will give you here 4 into 2 into 2. 4 into 2 8, 8 into 2 16, and minus minus, so it is plus, and 1 minus x square, and in the denominator you have 1 minus x square to the power 4. So you have 1 minus x square to the power 3, and in the numerator you have x into x. This is x square. So if you find out the third derivative of the function at x equal to 0, you see the third derivative, if you put x equal to 0 here, the first term will give you 4 and the second term will give you 0, because if you put 0 here, then this term will be equal to 0. So the third derivative of the function at x equal to 0 is equal to 4. Similarly, you can find out the fourth derivative. If you calculate the fourth derivative, it will be equal to 0, and if you calculate the fifth derivative, it will be equal to 48. Now you substitute the value of f0, f dash 0, f double dash 0, f triple dash 0 like this in the function, that is in the Taylor series expansion. The function is log 1 plus x divided by 1 minus x. The first term is equal to 0 because f0 is equal to 0. The second term is x divided by factorial 1 and f dash 0 is equal to 2. And the third term is x square divided by factorial 2 and f double dash 0 is equal to 0. And in the fourth term you have x cube divided by factorial 3 into the fourth term is equal to fourth derivative is equal to, sorry, the third derivative is equal to 4. And the this is the next term and this is the next term. So this term is equal to 0, this is 0, this is 0. So the final result, if you take 2 common, then this will be equal to x plus x cube divided by 3 into 2. Factorial 3 is 3 into 2. If you divide 4 with 2, here you have 2, so, and you have taken 2 common. So this term will be equal to x cube divided by 3, and this term is equal to 0, and this term will be equal to x5 divided by 5, because here you have 4 factorial. 4 factorial is 4 into 3 into 2. So 4 into 3, 12 into 2, 24. 24 divided by 48. If you divide from 48, it will be 2, and you have taken 2 common. So in the bracket you have x5 divided by 5. So this is the result of the expansion of log 1 plus x divided by 1 minus x by using Taylor series or Maclaurin series. And this formula you have to remember in many problems in mathematics or mathematical physics. You need the expansion of this function, that is log 1 plus x divided by 1 minus x, and you have to remember this value. It is equal to 2 into x plus x cube divided by 3 plus x fifth divided by 5. Thank you.